Hello students. Right now, we're going to learn how to find the chemical formula of a compound with all but one of its subscripts present. Additionally, we will be given the mass of the initial compound as well as the mass of a product that contains the element of our missing variable. Let's go check it out. A compound was reported in the literature as C23H34O6NX, where the X needed to be determined. 25.34 milligrams of this compound was combusted. After combustion, all of the nitrogen was found as nitrogen dioxide, which was weighed and determined to be 5.37 milligrams. What is the chemical formula of this compound? That is, what is X? To start, we will need to find out how many grams of nitrogen is present in the initial molecule. We obtain this answer by first calculating the molar mass of NO2. From the periodic table, we see the atomic mass of nitrogen is about 14 AMU, while oxygen is about 16, giving a molar weight of 46 grams per mole. The weight of NO2 is given as 5.37 milligrams, which we will divide by the molar weight to get 0.1167 moles. Since the problem tells us that all of the initial compound's nitrogen wound up in the nitrogen dioxide, we can multiply the amount of moles of NO2 by the atomic mass of nitrogen to get 1.634 milligrams of nitrogen. This means our initial compound has 1.634 milligrams of nitrogen. We can now subtract this quantity from the given quantity of 25.34 milligrams. The trick here is to know that we can use a cluster of atoms as a single unit with a new weight of 23.7 milligrams. That is, the C23H34O6 part of the molecule is treated as one unit, while nitrogen is dealt with separately. We can now convert grams to moles and moles to a mole ratio. We begin doing so by adding up the atomic masses of all of the atoms in the cluster of atoms. This gives us a molar mass of 406, which we can divide into 23.7062 to obtain an answer of 0.0583 moles of our cluster of atoms. As we found earlier, there is 0.1167 moles of nitrogen. We then divide both halves of the ratio by the smaller molar amount. In this case, it is 0.0583. 0.0583 divided by 0.0583 is 1, whereas 0.1167 divided by 0.0583 is 2. And there's the answer, C23H34O6N2. And there you have it. I hope that was helpful.